Sometimes in math, we come across fractions with a radical in the denominator, like 1 over the square root of 2. While there's nothing wrong with this, it's often more useful to have a fraction without a radical in the denominator. That's where rationalizing comes in. Rationalizing the denominator is a process used to remove radical expressions from the denominator of a fraction. We call it rationalizing because we're taking an irrational denominator and making it rational. Rationalizing the denominator makes numbers easier to work with, especially when adding, subtracting, or comparing fractions. Because we come across them so often in trigonometry, we're going to learn how to rationalize the denominator of fractions with specifically square roots. So, how do we do it? Let's find out. Let's look at a similar process, creating a common denominator. For example, when adding 1/2 and 3/4, I need to have a common denominator. I can accomplish this by multiplying 1/2 by 2 over 2, so I have an equivalent fraction with a denominator of 4. But why are we allowed to do this? Well, multiplying by 2 over 2, or by any number divided by itself, is the same as multiplying by 1, and multiplying a number by 1 does not change the value, only the format. Let's apply this process with a fraction that has a square root in the denominator. We know that we can multiply this fraction by another fraction that is equivalent to 1. But the question is, what will be in the numerator and denominator of that fraction? Well, it would be useful if we could get a number under the square root that is a perfect square, like 4. So let's multiply by root 2 over root 2. Multiplying the numerators results in the square root of 2, and multiplying the denominators results in the square root of 4, which can be simplified to just 2. This is why we were aiming to get a perfect square under the square root. It allows for the radical to be simplified, clearing the denominator of any radicals. So there we have it, a fraction that is equivalent to 1 over root 2, but does not have a radical in the denominator. Notice that when you multiply a square root by itself, like the square root of 2 times the square root of 2, the result is the number that was under the square root. This is not a coincidence. When you multiply a square root by itself, you are squaring the radicand. By squaring the radicand, we achieve a perfect square under the square root. Squaring a number and taking the square root are inverse operations, so squaring essentially reverses the effect of the square root. Let's put all of that together into some simple steps and take a look at one more example. To rationalize a square root in the denominator, first multiply the numerator and denominator by the square root in the denominator. Here, we'll multiply by root 3 over root 3. 2 times root 3 is 2 root 3. In the denominator, root 3 times root 3 is root 9. 9 is a perfect square, so now we've rationalized the denominator. We write root 9 as 3, and we're done. Great job! Now you've got another math tool under your belt. See you again soon!
Hey, hey.